Hey guys, Drew up here, and welcome to episode 14 of our 2D Java game engine series. Last time we left off, we set up the light map, and we have it rendering properly. So, get rid of that, we don't need that print out every time. So now we're actually going to implement the light. So we're going to need to create a new class, and I'm going to call it light. Okay? And our class is going to take in a public, we got to create a constructor. And our constructor is going to take an int radius and an int color. And that's all you got. That's all you need for a light. And I'm going to have some private ints. I'm going to have radius. I'm going to have diameter just for convenience and color. So radius equals radius. Diameter equals radius times 2. Crazy, right? And color equals color. And I need to set, I need to put this in front of it. I don't need to put this in front of diameter. But I will, just because I want it to match up. Alright, so we got our values. Now we need to calculate our lighting. We're going to generate an image, basically. So I do int y equals 0. And I start off with y because of how our arrays work. It is best to do y first, then x. It's easier on your CPU's cache and is therefore faster. We also need I almost forgot, a private int array. I'm going to call it light map. So the radius will have a light map. So y is less than our diameter, y++. For loop. Int x equals 0, x is less than diameter, x++. Alrighty, so we're going to basically generate a circle where the closer it is to the center, the more close to our color it is, and the further away from the center, the darker it is. Generating essentially this image, but with code. That's what we're going to do. Alright, so how do we do that? We need to first calculate how far are we from the center of our image. So I'm going to let's make it a double. And I'm going to call it distance equals, remember the distance formula? Math dot square root of x times x plus y times y. X squared plus y squared equals our length. And the square root of that. So now we got our distance from the center. Not really. This is the distance from the top left corner. Oh no, we need to offset it. So how do we do that? We got to go to each of our x's here and our y's, and I'm going to put them all in parentheses. And I'm going to take my x and I'm going to add radius to everything. Everything's going to get a nice good old boost of radius. So x plus radius. Actually, we want to subtract. We're going to subtract radius because I want it to be the top left corner to be negative. That way the center of our image is 0 and the top right of our corner is positive radius. So we're going to subtract radius from everything to get the proper distance. Good. So we have our distance. Now if our distance is less than our radius, right? Is it in our circle? You could say equal to, but I'm just going to do less than. Is our distance less than our radius? I'm going to, so if it is, right, we're inside of our circle. We need to set our LM at x plus y times diameter equal to something. Else, our LM x plus y times diameter is equal to 0. We're just going to set it to black, which is 0. All right, so now we need to know what we're going to set it to. We're going to set it to our color, but we need to modify our color to be based off of a power, right? So I want it to be close to the center. If distance is close to radius, then I want it to be close to the actual color. And the further away it is, I want it to be darker. So I need to do something similar to where are we at? Let's go to renderer. And basically, I'm going to do something similar to our image here. So how we're setting it equal to, we're taking the color and then we're multiplying it by a value. where here we're doing it 3 different values. I'm going to do this. I'm going to copy it, but I'm going to do it all to the same value. Oop, where am I at? Light. So we're going to set this equal to, boom. Now, we don't have PI, we have color. So we're going to take our color, do that. Boom. Now we don't have RGB. I'm going to make a new float, and I'm going to call it power. I'm going to set it equal to 1 for right now, just so we don't have any errors. And I'm going to change all of the R and G's and B's to be power. Alright, so I need to calculate my power. So power is going to be derived from our distance divided by our radius, right? But this has a problem, so our distance, right, if it's equal to our radius, will be 1. And the further away it is from the radius, it'll be 0. So this actually has the inverse property of what we want. I may as well make this a double. Doesn't matter, just so we don't have to cast it. So to inverse it, I need to subtract 1. 1 subtract distance divided by radius. And that should give us the proper power. Here we go. Now I'm going to get some getters and setters here. Source, getters and setters, just for everything. Right? Now I'm going to go back to my renderer, my game manager, and I'm going to give this class a test. I want to know if it works. So I'm going to make a new private light, because once again, I am very creative with my naming schemes. Light equals new light. The first is a radius, I don't know, 50. Color, I'm going to make it cyan, which is 00FFFF. Which isn't really a good color to make a light, but it's fine. It's fine, okay? So here, I'm actually just going to use this code because we don't have a draw light yet. I'm going to just modify it to do light.diameter. Same thing here, light.diameter. And this will be light.get LM. And this will be light.diameter. Not an image. Light.get diameter. So when we run this, oh, we got a null pointer exception. LM. Oh, we never initialized LM. LM equals new int array, and that's going to be diameter times diameter. Alright, so now we have a cyan light, which is appearing right here. Boom. It actually works. Now, I'm actually going to, for this testing purposes, I'm going to change this light, this image, I mean. I'm going to make it the size of my screen, which is 320 by 240, so we'll make a new 320 by 240. And I'm going to set it, I'm going to set it as a pattern. I'm going to set it to a pattern that has basically every color. I like using this pattern. I know it's a lot of blues, but it still will give us a good test. So I'm going to export it again to desktop, to Imagination Res, and that was test 2, right? Yeah, test 2. I'm going to override it. I'm going to modify it here. So I don't want to actually draw this where the mouse is. Right, our image 2 is just going to be drawn at 0, 0. Which we have a little blue light there. Right, but I notice a problem actually. It's not how big we want it to be. You see that? It looks smaller than it's supposed to be. Because it's drawing it at 0, 0. So up here in the top left is the beginning of it. 50 is not like down here. A little weird. The power might be wrong, which is a very possible. All right, let's go to my renderer. Not renderer. Let's go to my image. Light. Light is where we're going. Let's see here. What is it saying for power? Because power should be right. It might just be because it's blue on a blue image. But let's print out power when we do this. I want to see what numbers does it give power, right? So we go from 0. I don't see 1 in here, although it could get the 1. It's getting close to 1. Distance plus. This is really hard to see because it's so big. But, okay, what are we getting here? So our radius is 50, right? And this is at the bottom of our image. Right? I guess it's doing it right. Maybe I'm just thinking that it should be bigger. Let's try making our image bigger, or light bigger. Let's go for as big as our screen, 240. Let's go for height-wise, 240. How big is that? Yeah, I guess it is doing the right size. So now our light's all the way down here. There's quite a bit of gap. But this isn't exactly how we're going to do our lighting. So it's just for testing purposes. I have it rendering like this. So, yeah. Go back. Make it 100. That's a good color. So, we have our image, right? It's lighting up area. We have our ambient color in the sides, and we have our main right there. If we were to turn down our ambient color, it would make our light bigger because it would not hit the ambient color as fast. So let's find a darker color, like that looks like a good color to me. I'm going to set that right here. And thus we get a nice darker color. So yeah, it looks like it's a good size. Alright, now let's actually implement how we're going to render our images, or light. And the way we're going to draw our light is we're going to draw it in lines. And we're going to use those lines to determine if we have hit a pixel that generates a shadow or not. So I'm going to go down low. We're going to go to the bottom. I'm going to make a public void draw light. I'm going to say int off x, int off y. Let's start off with our light L. Okay. And there is our light draw. Now, we could do exactly what we did before, and we get a pretty fast light, right? What is our FPS at this stage, anyways? We're starting to get down low. This lighting does take up some of our processing power. Quite a bit of it, actually. So, but we'll continue on. You can always disable it later if you don't want it. It's fine. So, draw light. We're going to do something different. We need another method. It's going to be a private void, because I don't really want to have this be in it. It's going to be draw light line. And we're going to take light L. And now I need to know the start and the stop of my light line. And so I'm going to do that as x, int x0, and int y0 is the start, int x1, int y1 is the end. Okay? So now we're going to draw our light line. To start off, we're going to do int dx. This is our change in x is equal to math.absolute x1 minus x0. Int dy is equal to math.absolute. So it's y1 minus y0. Alright, that is our change in x and change in y. By the way, the algorithm I'm using is called the Brinham line algorithm. This is algorithm I got from Wikipedia, basically. It's drawing a line without using floating point math. It only uses integer math, which is quicker than floating point math. So we have int sx is equal to x0 is less than x1. Right? This is actually going to be an inline if statement. Is that true? We want to set sx equal to 1, else we'll set it to -1. Yep. And we need to do the same thing for sy equals y0 is less than y1 question mark 1, else -1. basically this is determining our which portion, like are we going in the first quadrant, second quadrant, third quadrant, fourth quadrant. By doing this, we're figuring out which direction we're heading in. Now we need to do an error is equal to dx minus dy, and we need an error 2 later on here. Now we need to start our while loop in order to generate our line, and we're going to do it while true because we're going to exit the while loop from inside the while loop. Basically, if our light hits, if we get to our location that we want to get to, we want to break, right? So if our x0 is equal to x1 and y0 is equal to y1, right? Break. We hit the location we were going for. We're done. All right? Very simple. Now we need to do a little bit more math here. So next we do error 2 is equal to 2 times error. That's why it's called error 2. It's 2 times the error. Now if our error 2 is greater than -1 times dy, then we're going to set error minus equal dy and x0 plus equals sx. So we're going to move on the x, right? Then we're going to have another one for error 2 is less than dx, and that's error plus equals dx, and this is y0 plus equals sy, and we're going to move on the y. And that is the basis of our line algorithm. So let's actually draw it. But before we actually do that, to actually draw the line, because that calculates the line, but we actually need to draw it here before we break, because I wanted to draw it at the location. I'm going to say set light map x0 y0 light dot get color. Now we don't need to get color, we need to get the light map specifically, and we're gonna do a little bit of math to figure out where we are on the light map here. So how can we do that? Well, I have it here in my old code here that I'm referencing because I haven't memorized this stuff. This one algorithm, I have it modifying it with the offset x and y, x0 and y0. So we might just do that, because right now we're passing it in based off of just generally where we are. So I'm actually going to do that. I'm going to have an int off x and an int off y. Right? So our get light map, all we have to do here is x0, y0, x0 plus y0 times light.get diameter, and that should get us our color. Right? Yeah. That'll get us our color. Now, in order to offset it, we need to move it. Right? I'm going to move it minus light that get L dot get radius and minus L dot get radius. But I also want to add on the offset x and the offset y to our x and y respectively. And that should generate our line, but we need to use draw light to call our draw line because it's a little bit different for how we draw the light. So how do we draw the light? Do a for loop, int I, let's do I equals 0, I is less than light that diameter, light, it's L, now at that get diameter. This is actually going to be less than or equal to, because we're going to have the same problem with the fill square where it'll forget a portion of it if we don't. All right, we'll just need this one for loop. Now we need to draw a light line 4 times, because we're basically going to divide this into 4 90-degree angles. Okay. So we have our light line. We're going to draw the top of it first. So I want it to start at the light radius, the L dot radius, right? And that's going to be true for the Y as well. The X and Y are always going to start. Also, we need to pass an L first because of how I drew it. And I'm going to copy and paste this for the others because we're always going to start at the center of our light. And then we're going to move to the outside. So I'm going to move by I and 0. So that will move across the top of our light. The next one will move I and light that diameter. That, not light, keep putting light. L dot get diameter. That'll move across the bottom of our light. 0 and I will move across the left of our light. And light dot get, not light, L dot get diameter and I will move across the right side of our light. The last thing we need to do is give it the offset X and offset Y, which is needed for calculating our screen position. Now we could directly add it here, but for generating our shadows, we'll need it in our light line. So we pass it on through, and that will generate a light. Now let's try drawing our light. We're going to get rid of this light code here. And I'm just going to say r.draw draw light. And we'll draw light, offset X. I'm going to say gc.get input.get mouse X. gc.get input.get mouse Y. Whoop. So now when I render it, oop, we had a problem. I think it went out of array, yeah. We're not actually checking to see if this is in position. So actually I'm going to make a new int screen X is equal to this X. Int screen Y is equal to this Y. And we need to make sure that these are actually on screen before we actually try and render them. Because if they're not on screen, we're going to have a problem. Right? Check. Screen X, yep. Index array out of bounds. What was out of bounds here exactly? Actually, our get, this might have gone out of bounds. Because it shouldn't actually set it out of bounds because of screen X. We'll do this anyways. Because we'll need it. To calculate it again for getting the screen location. But now if I run it again, will it still say out of bounds? Yes. And I believe it's this problem right here. We're actually going to implement a get value inside of my light. So we're going to go to the light. We'll make a public int get light value. Int X, int Y. And it's simply going to return our light value at that given spot. Right? But only if our X is less than 0, or X is greater than or equal to diameter, or Y is less than 0, or Y is greater than or equal to diameter. I just want to return black, which I'll just return 0. So there we go. Let's go back. Renderer. And I'm actually going to do a simple test here. So if light color is, or int light color is equal to L dot get light value, which will be our X0 and our Y0. If light color equals 0, just return. We're done. That should work. And then I'm going to change this code right here to our light color. And get rid of that. Alright, so now I run it. And there we go, we have our light. And it's following my mouse around just fine. So, we have a light. Let's implement the light block. This video is going to be a little long, but there's a lot of code. I need another image to test it with. So I'm going to pull back up our good old GIMP. I'm going to make a new, let's call it 64 by 64. Okay. I'm going to make a pattern, and we'll just use the wood pattern. What is that? That's not the good wood pattern. That's the good wood pattern. All right. And I'm going to export this as test 3. Actually, test 2, test 1. We'll override our test. Since we're already importing it, we don't have to code that again. So we have our test. I'm going to have it draw my image, or that draw image, and I'm just going to put it roughly in the middle of the screen. Roughly. And so now we have our nice little wooden piece. And you can see the light works as you would expect a light to work. But we want to have shadow. So I want this image to block my light and give me shadow. How do I do that? Well, we need to use the light block. So first I need values because our light block is an int. So I'm going to make some public static final int. Let's call it none, which is equal to 0. So there's no light block. I'm going to copy it, and then I'm going to make another one, and I'm going to call it full. So that's going to fully block the light. There's going to be some others, but for right now, I just want to implement full. Mainly because this video is getting a little long, and I want to get this video done. So, come back into our draw light line. So we check our area, and we have our full block. So I'm going to consider a full block. It's not even going to render it here. So if, right, LB at our screen X plus screen Y times our screen size is equal to light.full, I'm going to return. Simple as that. Now, how do we set the light block? Now that can be a little annoying, but actually what we're going to do is we're going to go to our image, and we're going to add a new value to it. I'm going to make a private int light block. I'm going to actually write this one out. So our light block, and we'll generate getters and setters for it. And it's going to, by default, be set to 0, but I'm actually going to change that just to light.none, which is 0, but it's more clear. So by default, nothing will change the light. Oh, we have a problem here. Wait, light. Oh, they're both set to 0. She's set to 1. So there. What now? Index array out of bounds. Screen X is out of location. Oh, because our screen X is not being tested to see if it's in bounds. Let's actually test our screen X. So if our screen X is less than 0, or screen X is greater than or equal to p width, or screen Y is less than 0, or screen Y is greater than or equal to p height, we are out of bounds and just return. Because we're going from our center outwards, and there's no reason to continue. There we go. So if we're off screen, we gain some FPS. When we're off screen, we come back in screen, we lose some FPS. That means it's working. So now what I want to do is I'm going to actually change it so that when we draw our image, right, I want to also set the light block value of that location to whatever our light block value is of our image. And to do that, I need to make a new, just going to copy set light map, right? And this is going to be set light block. And we don't need any of this math. We just straight up set it as the value. And change it from LM to LB. And then, whenever we draw an image, right, we are setting our pixel, I also want to set light block at X plus off X, Y plus off Y to our image.get light block. And I'm going to do that for all of our draw images. And anything else? This one right here. Actually, we don't have an image for our fill Rex. So we're just going to do that. And so, still haven't got it how we want it. But now, if I go in, and it's our image 1, right? Yes, it's image 1. I'm going to say image dot set light block to light dot full. Now, if I do that, the magic should happen. Magic did not happen. Houston, we did not have magic. What is our problem here now? We have our image. We're drawing our image. We gotta take our Z buffer into calculation with our light block. Maybe that's it. No, it shouldn't be it because they're all in the same buffer. Let's go back to our renderer anyways and actually put that in the place. That is important. All right, our draw image has light block. All right. So, but our light block should also consider our Z value. So I'm going to copy and paste that. And I'm just going to change that over to PW. Just like that. But we have a problem. What is our problem? It should be setting our light block properly. Oh, I know what's going on. I know what's going on exactly. I forgot. So, our light, in order to generate the shadow, has to be drawn last. Right? It's still not drawing it. It should be drawn last and it should work then. That's weird there. Because it should draw it then and there. Oh wait, it's not rendering them last because these are alpha images. Because alpha images are just in general rendered last. So if I change that back, we get the shadows. Oh my gosh. That took way too much debugging. But yeah, so now it actually blocks our light line. And you can see our light now works with shadows. Oh my gosh. So, the problem we have now is that lights have to actually be drawn last. Right? Just like our alpha images. They have to be drawn last. You see that there's a common theme there with graphics. So I need to modify our renderer to collect our lights in a list and draw them last, which will be the next step in our lighting engine, the lighting tutorial. So that's going to be it for today, though. We got our light. It's drawing our light with a shadow. What more can you ask for? You know? So that's going to be it for now. Comment, rate, subscribe, and thanks for watching.